All right, we looked at the slope formula. So when we were given 2 points, we could plug those 2 points into the slope formula, calculate the slope, and woo, we're done. Now we're going to look at, well, what happens if we're not given 2 points? We still need to find the slope. We don't have a graph. We don't have 2 points. We have a table. How can we find the slope if we know there's a linear relationship? Well, as it turns out, we do have points. In fact, we have 4 points. We have an xy here, an xy there, an xy there, and an xy there. And we have 4 points to choose from. We actually have lots of options. We only need 2 points to find the slope. And so pick the easier ones. I'm going to go with this point here and this point right there. And I'm going to use my slope formula. Slope formula, again, was y2 minus y1, the rise, over x2 minus x1, the change in the horizontal direction. So if I use that formula, remember this, my x's are on top here, my y's are on the bottom. And so y2 minus y1, I've got -1 and 1, 1 minus 1. And x2 minus x1, so I've got my x2, my x1, 1 minus 0. I end up with a final answer of -2 over 1, which is -2. Either one of those would be correct. And we got our slope. So if you're given a table, you pick any of those points, 2 of them, they don't have to be next to each other. Pick any 2 of those points and plug it into your formula. Give this one a try on your own. Use the same idea, use the slope formula, find the slope. I'm assuming you paused it. I'm assuming that you tried it on your own. The slope for this one ends up being 2. Or, of course, you could have 2 over 1. The slope for this one now, okay, we don't have a table. We don't have points. We don't have a graph. We have an equation. We still have to be able to find the slope. There are multiple ways to do this. We'll learn about other ways later. But the way we have right now is that if we had 2 points, if we had a point here and, say, a point right there, then we could use our slope formula to find those 2, or find the slope from there. So we need 2 points. We need 2 points to find the slope. Let's look at the equation. We actually have a method of creating 2 points based off that equation. We can find the x and the y intercept. Woohoo! So x-intercept, we'll start with the x-intercept. If I want to find the x-intercept, I leave x alone. I pretend y is 0 because the x-intercept is when y is 0. And we see that 4x equals 16. I know that x equals 4. So x is 4, y is 0. I have a point. Now let's do another one. We'll do the y-intercept. So the y-intercept. Again, I pretend that x is 0 because when the graph intersects the y-axis, we end up with a y value and x is 0. So minus 2y equals 16. Negative 2y equals 16. So y would have to be -8 because -2 times -8 equals a positive 16. So 0, -8. Now that I have those 2 points, I can apply my slope formula. So again, I have the change in the vertical over the change in the horizontal, rise over the run. I get -8 minus 0 and 0 minus 4, which gives me -8 -4ths, or 2. Of course, you could always write 2 over 1, but we'll go with 2. And that's my slope then. The slope would be 2 based on that equation right there. It's a lot more work, but it's just building on these things that we know. We know how to find the x and y intercepts, so we have 2 points that we can use, and then we can use those 2 points to find the slope, which is the rise over the run. Give this one a try on your own. Same idea. We've got an equation, 2x plus 3y equals 12. Create 2 points that you can use, and then apply the slope formula to find the slope. I'm assuming you paused it. I'm assuming that you tried it on your own. the slope of this line is negative 2/3. If you did not get the answer to that one or this one, make sure that you watch the appropriate linked video and see how it's done.